Okay, this is geometry 3.3, proving lines are parallel. It's pretty similar to 3.2, parallel lines and transversals, except now we actually don't know that the two lines are parallel. We want to show or actually prove that they're parallel. So there's actually 4 different ways that you can show or prove that the lines are parallel. Basically, we're just taking the converses of the 4 theorems from 3.2. So if you remember the corresponding angles theorem, it states if 2 parallel lines are intersected by a transversal, then the corresponding angles are congruent. So the corresponding angles converse states if corresponding angles of 2 lines intersected by a transversal are congruent, then those 2 lines that are intersected by the transversal are parallel. For example, in this diagram, a pair of corresponding angles are angles 1 and 5. I think it should be somewhat obvious that those are not the only pair of corresponding angles, but it just takes one pair of corresponding angles to be congruent for these 2 lines L and M to be parallel. Again, notice that it's not given that L and M are parallel, but if you know or it's given that a pair of corresponding angles are congruent, like angles 1 and 5, then those 2 lines would be parallel. Then line L is parallel to line M. So I could state the corresponding angles theorem converse as such. Again, we're just taking the converse of the corresponding angles theorem. But if 2 lines are intersected by a transversal, not parallel, just 2 lines, intersected by a transversal, and a pair, again, it just has to be one pair of corresponding angles are congruent, then the 2 lines are parallel. So that shows, or in other words, proves that the lines are parallel. Again, in this case, lines L and M. And then you could do something similar for the alternate interior angles converse. Okay, for example, in that diagram, let's just say, kind of starting over here, we don't know, 1, that the lines are parallel, and then 2, in this case, that angles 1 and 5 are congruent. Those are corresponding angles. I could have said angles 2 and 6 are congruent. Those are also corresponding angles, 3 and 7, or 4 and 8. But moving on to theorem 3.6, or the alternate interior angles converse. I could take the majority of the corresponding angles converse and then just change a few words. If 2 lines are intersected by a transversal and a pair of, now instead of corresponding angles, it could be alternate interior angles are congruent, then the lines are parallel. For example, angle 3, first of all, that's an interior angle. And then the angle that's alternate interior with that is angle 6. If those 2 angles are congruent, then that proves or really ensures lines L and M are parallel. So if 2 lines are cut by a transversal, same thing as intersected. And a pair of alternate interior angles are congruent, then the lines are parallel. Okay. And then really I could just change one word for theorem 3.7. So now again, I'm going to start over here. I don't know, 1, that the lines are parallel, or 2, that angle 3 and angle 6 are congruent. But for theorem 3.7, Again, I could just change one word here. If two lines are cut by a transversal and a pair of alternate exterior angles are congruent, then the lines would be parallel. So I'm going to take this theorem right here and just change one word, alternate interior to alternate exterior. I could just change the prefix, in other words. A pair of alternate exterior angles, such as angles 1, that's an exterior angle, putting 3 tick marks in there. And then 8 is the alternate exterior angle with angle 1. That would ensure that lines L and M are parallel. Yes, it could have also been angles 2 and 7. Okay, and then lastly, for the consecutive interior angles theorem, now you need to change a little bit more wording than you had to do for the previous couple of theorems here, because consecutive interior angles such as 3 and 5, those aren't congruent. If they were congruent, that doesn't ensure that lines are parallel. If they're congruent and they're each 90 degrees, then the lines would be parallel. But they could be congruent and then the lines not be parallel as well. But for the consecutive interior angles theorem, converse, if I have a pair of consecutive interior angles, such as angles 3 and 5, those are consecutive interior angles, if they're supplementary, in other words, they add up to 180, then the lines would be parallel. So you could say if angles 3 and angle 5 are supplementary, or you could also say if the measure of angle 3 plus the measure of angle 5 is equal to 180, then the two lines L and M would be parallel. Okay. So basically you could state the consecutive interior angles converse as such. If two lines are intersected by a transversal, and a pair of consecutive interior angles are supplementary, then the lines are parallel. Or again, you could also refer to them as same side interior. It's the same thing. But note that they have to be supplementary or add to 180. And then I'll mention at the same time, just keep in mind, if you're asked, well, how do you know that the lines are parallel? Say you have a pair of alternate interior angles that are congruent. You wouldn't just say the alternate interior angles theorem, because for the alternate interior angles theorem, that says that the lines are parallel already. It would be the alternate interior angles theorem converse. Okay. Kind of as always, every little detail matters. Let me show you an example in my diagram how you could determine that the lines are parallel. And I kind of already did. I just didn't show or put the tick marks in the diagram to show that the lines are parallel. So if you know this, the measure of angle 3 plus the measure of angle 5, since those are consecutive interior angles, they're supplementary, then you know that the lines are parallel. I can make my little arrows on the lines, or I could also say this as well. Then line L is parallel to line M. That's the other way that I could write it.